Good morning. My name is Pranavi, and my topic is ensuring confidentiality in the cloud of things. What is the cloud of things? Firstly, the cloud of things integrates billions of IoT devices that generate massive data streams with scalable storage and processing power of cloud computing. This synergy enables transformative applications from smart homes and intelligent healthcare to advanced industrial automation and smart cities. And it is a backbone of the connected future where data from everyday objects is harnessed to create smarter, more efficient and responsive environment. Why confidentiality matters in the cloud of things? Let's say confidentiality matters not only in the cloud of things but in everywhere because let's dive into the cloud of things. It has a storage and multiple things in it. It may list to the sensitive data at rest. The cloud of things handles highly sensitive personal and financial industrial data. It may be other data too, medical data or any other entrepreneur business details or any other details. Breaches can lead to identify theft, corporate espionage, and disruption of critical infrastructure. And the next thing, why confidentiality matters? Erosion of trust. Public trust is a major fact and is a fundamental for widespread adaptation. A single major data breach can severely undermine user confidence and hinder technological process. And the third one is the regulatory compliance. Strict data protection laws like those in India, we have IT Act, which IT Act 2000, which mandates robust confidentiality measures. Non-compliance can result in heftiness and legal implications. And the fourth one is human impact. For individuals, a breach of medical IoT data, for instance, could expose deeply personal health conditions leading to discrimination or other emotional distress. For this, we have to protect the story data. Protecting the data can impact human dignity and safety. Key security challenges to confidentiality. The first one is identify management complexity. Managing unique identities for billions of diverse IoT devices, especially with the transition to IP address version 6, presents a massive challenge for authentication and authorization in the insecure data transmission. Data frequently travels over wireless networks, making it vulnerable to ever-dropping and interception without strong encryption and secure protocols. And third one is the resource constraints of IoT devices. Many IoT devices have limited processing power, limited memory, limited battery life. For this, restricting the implementation of complex cryptographic algorithms and extensive security features. And the final key feature is the dynamic service discovery. The constantly changing and dynamic nature of service discovery of cloud of things environments, complete, maintaining consistency and secure access controls. Encryption techniques for data confidentiality. There are three types of data confidentiality techniques, which are the two-layer encryption, ABE, which is attribute-based encryption, PKI, and symmetric key crypto systems. Now, when it comes to the two-layer encryption, this method involves the two types, which is coarse-grained encryption and the fine-grained encryption. Coarse-grained encryption is done by the data owner, and the fine-grained encryption is done by the cloud provider. By offering the granular control, we can enhance the protection of the data. And when it comes to the next attribute-based encryption, which is ABE, which allows access to data only if a user possesses a specific set of attributes. Which is, if let's say an example, a doctor and a department head he or she has certain specific role, ensuring that it has its confidentiality without any individual key management. It doesn't open. It is an end-to-end encryption. And the last one is the PKI, which is public key infrastructure and symmetric key crypto systems, which is a secure key exchange and digital signature combined with symmetric key and crypto systems for bulk data encryption forms a robust cryptographic foundation. The next one is the emerging technologies and enhancing confidentiality. When it comes to the blockchain, it is an immutable data. Blockchain offers a decentralized, immutable ledger for recording data, transaction, enhancing integrity, traceability, making unauthorized modification extremely difficult. And the next one is a machine learning for threat detection. Machine learning is widely and vastly used for analyzing the data sets to identify anomalous behavior, to predict the same patterns, same insights, to predict these potential threats, and also to mitigate security, and also to mitigate the breaches in real time. And next one is the edge and fog computing. Processing data closer to the source at the edge and fog layer reduce the volume of sensitive data transmitted to the central cloud, minimizing exposure risk. The next subtopic is compliance and legal framework in India. As we earlier know, it has legal acts, which is IT Act 2000 mandates that Information Technology Act 2000 specifically, it is a section of 43A. It stipulates that corporate bodies having handling individual sensitive data, sensitive personal data or information, which is known as SPDI, must implement reasonable security practices and procedures. These SPDI rules has certain things which the information technology, which also known as reasonable security practices and procedures and sensitive personal data or information. In this rule, 2000 level provide a detailed framework for protecting sensitive personal data or information, including categories of data and deemed sensitive. The third one is the liability and accountability. Companies and even top management can be held liable for negligence leading to data breaches. This emphasizes the critical need for robust security measures and regular audits. And the fourth one is the audits and grievance redressal. Mandatory certified audits and effective grievance redressal mechanisms are crucial for demonstrating compliance and ensuring the accountability in case of incidents. Practical examples and use cases. This cloud of things examples are confidentiality is not just a theoretical, it's a practically necessity across various sectors. Either it can be education, either it can be healthcare, either it can be industrial sector, either it can be a business. Whatever it is, confidentiality matters in everywhere in every sector. Let's say take some examples. Smart healthcare. Encrypted patient data from wearable and medicine devices flowing securely to cloud-based electronic health. Because in nowadays, maintenance of records has gone less, and maintaining electronic devices, maintaining their data in the computers are give more security in compared to the pre-traditional methods. And the second example is the industrial automation. Secure transmission of sensor data from critical infrastructures like power grids and manufacturing plants and cloud analytical platforms, preventing unauthorized access and cyber physical attacks. And the third example is the telecom sector. It is one of the major sector which is very important have confidentiality Because in this safeguarding communication networks include user data, network operational data, and other details of a particular user as essential critical infrastructure, maintaining service integrity and also building a national security too. Here's the conclusion of building trust through confidentiality. Confidentiality is not merely a feature, it is the foundational pillar on which is the cloud, which is the entire cloud of things must be built. And here you can see the graph. User trust and adoption is a major but it should be placed first, and the compliance and ethics, encryption and access control. These are the by combining these things, robust encryption techniques, similar access control, adherence, comprehensive legal framework. In like India IT Act 2000, we can create a secure environment, a human-centric approach that prioritizes privacy, ensures confidence, and widespread adoption of cloud of things technologies. Thank you.